Thank you, Ashley. Hi, Jared Hansen here. In this webinar, we're very excited to be offering something very new for us. Throughout our history, RANSIM has been growing our offerings alongside Ansys in the key areas of finite element analysis, computational fluid dynamics, and electromagnetic simulations. In more recent years, Ansys has, through a number of acquisitions, taken on a more leadership role in the field of optics and photonics. And RANSIM will be growing into that field as well. Today marks a big step towards that goal. With all that being said, I'm excited and pleased to introduce to you today Yaelle Olivier. Yaelle joins RANSIM from Florida, and she'll be leading our optics and photonics team. She has a rich background in simulation and development of lenses and photonic systems, and will use that knowledge to not only grow our team in this rapidly developing field, but also help you, our customers, grow your tools and skill sets using the suite of Ansys optics and photonics tools. With all that being said, Yaelle, the floor is yours.
Thank you, Jared. So hello, everyone. Good afternoon. If it is afternoon your time, I am on the East Coast. So I'm Yaelle Olivier. I'm the optical simulation specialist here at RAND Simulation, obviously a Ansys certified elite channel partner. So I'm just going to go over today like an introduction to the optics and to your product designs, basically the full portfolio of what Ansys offers as optical software. So with that being said, I'm just going to dive right into it. So a quick overview of our objectives and agenda. We're going to go do an overview of all three optical softwares, pretty high level first, and then following that will be a deep dive into Lumerical, Zemax, and SPEOS, which are the optical softwares. And then after that, we will see examples of product synergy workflows between all of the softwares. In the images here, I have the James Webb Telescope image and the telescope itself. I thought this was pretty cool because, this was in recent news, and also they use Zemax to design their telescope. So I thought that was pretty cool. So these three products gives us the end-to-end complete portfolio with Ansys. We start on the left side with the smallest structure size domain, and then on the right side, which would be SPEOS, has the larger scale. So going back to the left side, Lumerical, it really dives deep into the photonics side and micro/nano optics. It's really more for circuitry modeling or really, really tiny optics modeling. Then in the middle, we have Zemax, which is an optical component modeling. Usually it's used in isolation for lenses or within lens systems. It's currently an industry leader for the space of optimization for lens stack imaging or illumination. This is also very heavily used in the optomechanical tolerancing space for optics. And then at the far right, we have SPEOS, which we're bumping up the scale to full system modeling here. With SPEOS, we can take information from the nanostructures, which would be Lumerical, or from optical modeling with Zemax, and applying them together into a complete system into SPEOS. SPEOS mostly is used for camera, sensor vision, or human vision, and basically seeing how light surrounds an area. So to go over this again, kind of broadly, we see that Lumerical and Zemax are the fundamental design tools. So this is really where you get nitty-gritty with your optimizations, your designing. And then the Ansys SPEOS is more of a sales and demonstration tool. You can still design in SPEOS. It's usually more geared towards the LIDAR design, but what we often see is that our customers will actually use SPEOS with their customers to show them how lighting will affect a material or area. So to quickly go over how these work together, we can do a photons to electrons camera system, for example. So when you want to take a picture, you have a scene. So let's say this is the flower in this, the flower in the little pot there. You have your scene, you want to capture it. So you use optics, like your regular camera optics, lenses, you're focusing the light from that scene onto a point. The point on the other end is usually your imager, which will be a sensor or detector to capture that light and turn the photons into electrons. To use this in the software scene, we can say that the scene is SPEOS with how the illumination works. Zemax is your optical modeling for your lens design, and Lumerical is turning your photons into electrons. We also see this with the LIDAR system. So we start at the beginning with Lumerical by creating light. Then we go into your Zemax for your optics, back into SPEOS, back into Zemax, and then back into Lumerical. So it doesn't have to be a fully linear system. We can definitely overlap a lot with all of these softwares. I think it's really important to talk about Ansys's optical mission statement here. So I'm just going to read it so we can also all understand it together here. So to accelerate the product development for complex optical and optomechanical systems through streamlined optical simulation from nanostructure to full system and seamless multi-physics simulations. That's a lot of words. Basically, how we want to see this is there are two main strategies that Ansys really wants to focus in on. Basically, the first system is that we can connect all three optical softwares together to make a streamlined workflow to allow customers to do things they couldn't previously do, because now we have seamless integration through each of these products with one another. The second being to connect our optical space with the other physics, connecting to FEA for things like structural or thermal analysis of optical components, connecting to fluids for turbulence type analysis. This is where we're looking to go with the optical software tools, is really to be able to connect to all of the multi-physics realms. So jumping straight into an overview of Lumerical, I wanted to kind of reiterate that we are looking at optics and photonics, although we usually kind of just use one word to describe both. Photonics is more of the physical science of light, like your photon, that's how you remember it. It's how do we start light, how do we, process the light, all of that, that's photonics. Optics is more of how do we shape the light, how do we get the light from point A to point B, how can we focus the light. It's more of molding the light, whereas photonics is the light. So Lumerical kind of goes into both types, optics and photonics. We have the integrated photonic system. It's like silicon wafers, and it kind of goes in more into like a circuitry type. So a lot of electronics with photonics components. We see this with photonic interconnect, communications, data transfer. This is really where the integrated photonics play in. On the other side, we see that we have the more traditional optics and photonics space, which is more in line with Zemax and SPEOS. Here we can optimize diffractive gratings, we can do meta lenses, nano lenses, micro lenses, OLED display stacks. You may be wondering, why don't we just do that in Zemax? Zemax is a ray tracing tool that allows you to do this, but when you get into such small components, it's actually more helpful to use a system like Lumerical rather than just a ray tracing tool. So photonics is everywhere and growing. So basically we see Lumerical being used in our smart homes, our smartphone sensors for very fast data transfer. We see it in the industrial IoT systems. We also see it in infrastructure and security, supporting 5G and optical communications. We also see it emerging more and more in the new healthcare medical technologies for, seeing diagnoses and the lab technology. And then in the center, we have the optical transceivers, which connect all of these together. They need to be able to support a large amount of bandwidth, which is where we can start using Lumerical or Photonics within the circuitry to help increase the speed of that. So some of the application spaces that we see for Lumerical is very much datacom. We see camera sensors with the AR and VR displays. We can also look in the automotive section where we see how we can start creating detectors for LIDAR, as well as in the lens design space with the nanostructures, diffractive gratings, and we're increasingly seeing it in the quantum computing section as they're starting to use more and more photonic integrated circuits. So a photonic integrated circuits, this is kind of an example of one. Basically, a photonic integrated circuits is light going through some kind of silicon waveguide, which is an optical structure that directs light from one area to another. But because it's on such a small scale, you would need the simulation software to see how the light is propagating. In the top video there, we saw that the light was bending around the corner, whereas on the bottom, we see that it went through a right angle, and we could see how that was affecting the light. So if we want to see that again. Anyway, I'm just going to skip over that. But anyway, so being able to kind of see on a nano scale how the propagation of light is going through a waveguide is really, really important. So the workflow through photonic integrated circuits can be described in like two halves. The first half is the building block section, like splitters or ring resonators. The fundamental building blocks of a photonic circuit are as such. These are similar to how we see resistors and capacitors on the electrical engineering side of things. They're really just the building blocks within the circuit. The second half is similar to the circuit itself. So we have Lumerical interconnect platform. So basically what we're having is your first half, you can either build your quote unquote resistors, and then in the second half, you can just start putting all those building blocks together. Once you actually start putting all these together, we can actually file those straight into Cadence, which is which can use a photonic circuit with the electrical circuits as well. So you can basically do either your individual building blocks, or you can just put all the building blocks together. Usually we see that people are usually focused on doing one or the other, and Lumerical is very good for either. I'm going to take a quick pause. Jumping right into Zemax now. Fundamentally, Zemax, it basically just helps engineers get light from point A to point B. It's used to design the optical system like lenses or reflectors with materials and coatings, optimized for each design, keeping in mind the order of these components and the quality of the image on the other end. So Zemax is very optics-based, whereas Lumerical is more photonics-based with micro optics. Zemax is more just optics. So we're just more modeling how light goes through a system. So when we're starting to look at the actual real physical applications of optics, it's never just looking at the straight optical components. We also need to look at the mechanics and electronics that will impact the optics itself. So there is a need to see how the optics integrates with the rest of the system and optimize the structure together. And then we also want to make sure that once the system is together, it will still meet the optical requirements specified that it did in just the ray tracing tool. It's very heavy in the optomechanics space to make sure that the result is as intended from simulation to physical design. So some of the key applications we see Zemax being used for is obviously lens design. We see that in cameras, smartphones, telescopes, lens stacks, focusing lenses, etc. laser material processing, and then the rest is kind of a snapshot of the rest of the core applications for Zemax products. We do also at the bottom of the slide see the flash LIDAR system and the heads-up display systems, which will also go into SPEOS. So we do start seeing that some of these softwares are starting to overlap, which is a good thing. So with the Zemax software, we have its flagship product, which is OpticStudio. So usually when you're talking with someone, you're talking with an engineer, they'll say, oh, I work in Zemax or I work in OpticStudio. The two names are really used interchangeably. But to be clear, Zemax is the brand, OpticStudio is the product. So OpticStudio has two systems in it that can either do sequential mode or non-sequential mode. So sequential mode is more of like your straight lens design, just getting from point A to point B with a light, seeing how it looks on the other side. Whereas non-sequential is more of like your illumination mode, seeing if there's stray light in your system, seeing how it really bounces off different materials. The second product of Zemax is the OpticStudio Star module. Basically, this new module, this is like a year old. This is very new. It basically addresses the structural, thermal, and optical performance analysis, also known as the STOP analysis. The idea here is to have a connection between optical analysis and FEA analysis, like taking data from Ansys Mechanical and seamlessly bringing it back into the optical analysis, and then seeing how does that performance look. So currently, we do see when we're trying to go from one physics to another, let's say like mechanical to optics or even electrical to optics, there's definitely a disconnect within the simulation softwares, which causes a lot of problems. It's really annoying, and then you don't even want to do the workflow. So we're really trying to make it so it's easy to go from one to the other, so you can continuously keep your workflow going, and you don't have to just do everything in one and then send it to one and then that's it. We want to be able to have it so you can jump back and forth and keep working. So that's where really the STAR module helps, especially with the mechanical side and doing thermal analyses. To mention quickly as well, in Zemax, there's also Optics Builder, which is more of the manufacturing, like once you are done your design and you want to optically start manufacturing or start looking at your design that way, that's where Optics Builder comes into play. But usually what is used more often is OpticStudio. So after Zemax, now we're going to go straight into SPEOS. I know I'm going pretty quickly, jumping through all of these. So SPEOS simulates a system's optical performance and evaluates the final illumination effect based on either human vision, sensor vision, camera vision. You have it. This also works on like lighting system modelers and analyzers. You know, we can obviously look at the human vision sort of things. We can see the optical sensor testing, heads-up display designs, far infrared extension designs. This is really when you're looking at the macro level of what light can do. Rather than you focusing the light, you're seeing the light around you. So some of the key applications or industries that we see SPEOS in, obviously we see it in lighting, so we can simulate how lighting will be indoors, outdoors, dependent on, you know, if there is a sun out, if it's dark out, if it's rainy, all that. One of the largest users of SPEOS is in the automotive industry, where they use the heads-up displays, LIDAR, and then even just seeing how the lighting is affected within the car, or like how the materials interact with the light, how the sun reflects off the dash, things like that. And then we also definitely see it in the medical and aerospace and defense industries as well. Now that we've gone over all of our all of our softwares, there are all three of them, I kind of wanted to show this slide to show examples that we can really start interconnecting all of these softwares to be able to work together. And I think that's the biggest thing that I really want to touch upon today is we have we can separately use each of these products, but we can also very much put all of these within the same workflow and have them all work really, really well together. And as I touched upon earlier with the fundamental design tools, the connection between Lumerical and Zemax is really appealing to, if you currently use Zemax and you're thinking about Lumerical, we can talk about that, but usually if you have Lumerical or Zemax, you kind of want the other, depending on your application. So I just wanted to highlight in particular this example. So again, if you're designing of some type of optical system within Zemax, often these systems, you're trying to make them smaller and smaller. And when you're doing that, you need to introduce components like nanostructures or microstructures. The thing is, when you're starting to get within these very tiny structured optics, you can't always design them purely with ray tracing tools. So we have this workflow that allows you to simulate for example, this diffraction grating. So you can actually design the diffraction grating within Lumerical to create a surface property file, and then we can directly feed that into Zemax or SPEOS for another example. We can do SPEOS or Zemax, but Zemax would be like the ray tracing tool. How does that diffractive grating fit into the system? And then SPEOS would show you the end product. How does that look in real life? And we can see in the video there under the SPEOS that's how a diffractive grating works. You take a spot of light and then it shoots in all different directions of rainbow in a very simplified definition of a diffraction grating there. So lastly, I just wanted to show another example of how this system can all work together within the LIDAR pipeline. It really addresses that we can use, we can start with Lumerical, go through our optics softwares, go back into Lumerical with the detectors, and then at the end, we can actually plug that back into another Ansys software that's not necessarily optical, like Ansys Autonomy. So this is really just, we're trying to expand the experience with optics and connecting that within the multi-physics space as well, to make the workflow a lot easier. And this, I think, really paints a full picture of all of the tools working together. To conclude, I wanted to share one last slide because it kind of summarizes the key applications for each of these products. So as I touched on before, Lumerical, we're looking at datacom, quantum computing, things like your AR, VR, and display analysis. Zemax is really the lens design for sure, in the laser material processing, laser welding, AR, VR systems as well. And then SPEOS again for the larger scale systems with a huge presence in the automotive industry, cameras and displays, and really helps demonstrate how your lighting looks, how, human vision or camera vision looks. So why RAN simulation? So RAN simulation is a Ansys certified elite channel partner, as we said before. We are one of the only channel partners currently to be allowed to start selling and supporting their optical systems or their optical portfolio. So what we can do is help the sales support and trainings. If you have a question, you'll most likely be directed to me right now, and we can help you figure out that your question right away. You'll definitely be in contact with an engineer, not just a salesperson. And then we also do consulting. So if your industry or if your company is not necessarily looking for buying the actual optical software, even having an optical engineer, you really just want to have a prototype or some sort of design made, you can definitely consult us out on that. Any questions?